today about sums of geometric sequences. So we did terms yesterday, we're doing the sums today. When we have geometric sequences, there's two kinds of sums. We're only, it looks like, going to deal with one of them today. We'll probably deal with the other one tomorrow. Okay? So specifically, we are looking at finite sequences. Finite means it stops somewhere. Okay, so this sequence is going to stop. Right? There's an end to it. Whereas infinite means it goes on forever and ever and ever. There's another formula for that. Okay? I told you one of the formulas was going to be ugly. This is the ugly one. This one I think is probably a little harder to memorize. Not that I wouldn't try, but this one I think if you can remember the other four, you can match the other four, this would be the leftover one. Okay? Alright. So S sub n is the sum of the first n terms. Just like it was the first n terms. Just like it was for arithmetic. Okay? The other thing is looking for clues in the formula. If it says geometric, there better not be a common difference in the formula, right? There better be an R in the formula. If there's an R in the formula, you shouldn't be writing it down for arithmetic. Okay? So you got to look for those clues. Right? A sub 1, what's that mean? First term. Always. The first term. And then the R, there's two R's this time. What does the R stand for? Ratio. Good. Or common ratio, really more specifically. And then what's the N stand for? Number of terms. So they gave us all the same variables that we've been working with, but just they put them together differently. And that magical formula gives us the sum of a finite geometric sequence if we were to add up all the terms. Okay? All right. So we're going to use that formula. Okay. Everybody got it down? All right. So we're going to find the sum. That looks kind of funky, though, doesn't it? Right? So let's talk about we need for this formula. Let's write down the formula. So S sub n equals A sub 1 times 1 minus R to the n over 1 minus R. All right, let's fill in. You know, I like to fill in what I can. Okay. So what's my n value? My n value. It says we're going from 1 to where? 9, right? We learned that notation earlier this week. So 1 to 9. So I know that my n value's got to be 9. Okay. It's really hard for me to tell what the first term is, but I could plug this numbering, couldn't I? Whatever's down there on the bottom, I can plug in. I'm going to show you a shortcut here in a second. Let's plug it in. So we've got negative 2 to the 1 minus 1. What's 1 minus 1? 0. So negative 2 to the 0 power is, so my first term is 1. And then I've got to figure out my ratio. I don't know what it is. I know that my n power here is going to be 9, but I don't know what my ratio is. Okay? So, if we go back to yesterday's formula, yesterday was A sub n equals A times R to the n minus 1. That one. Okay, then this. Okay? And see, look in front, we have an invisible one, not an imaginary one, right? Because that's a 9, right? But an invisible one is there. You see how that invisible one is actually the first term, and that's what we calculated? All right, so what's our ratio got to be? Look at the formula. The R is to the n minus 1 power. What's the R? Negative 2. So it's kind of hidden in there. So the R is to negative 2. Okay? Where you can't use, so I didn't have to do this calculation. I could use a shortcut. Where you have to be careful is when it doesn't start at 1. The ratio is still going to be in there, but your first term went here. Okay? If it starts at 0, or if it starts at another number other than 1, it's okay if it doesn't say n minus 1. It could say n. Sometimes it'll just say n, and the ratio is still right there. All right, let's see if I can, actually at this point, hit buttons on the calculator, aren't you? I want you to be really careful in the way you type that. You need to do 1 minus a parentheses negative 2 to the 9. On the bottom, you can turn the double negative positive. Okay, so everybody take a minute. Don't call out the answer yet. We just want to say, practice putting that in so you can get it in right. n value? Give this one. What's our n? 6. Even though it has funky i's in it, right? We're not worried about it being i's or n's or k's or j's or whatever it is. It's still in the same format that it was before. All right, what's your first term? How short here? Okay, let's think about this formula again. A sub n equals a sub 1 r to the n minus 1 power. Okay, what matches with this position here? The 32, right? So there's your a sub 1. What's the ratio? One more, the thing in the parentheses, right? That's kind of the ratio. Again, if I wasn't confident in my first term, could I plug 1 into it? And that would calculate it for me. Okay, but 1 minus 1 is 0, so we can zero out the 1 fourth, make the 1 fourth 1, and 1 times 32 is 32. All right, so we're going to go into our S sub n equals a sub 1, 1 minus r to the n over 1 minus r. Again, writing it out every time, so let's just memorize it. All right, S sub 1. 6, good. All right, what's your first term? 32, good. What's our ratio? 1 fourth, and we're going to raise that still to the 6th power. 1 minus 1 fourth. All right, I'm going to help you put it in. I'll get it put in. You guys start. But if you need help, I want not only a fraction, but a decimal. Okay? The fraction is going to be fairly ugly. Okay? I got to get my calculator. I'm going. We use a lot of control divides 3 times, right? And you can turn the 4 and 4 to 0.25, that's okay. But I'm trying to go with what's there. Okay, so if you need to follow along, I'm going to do it. So 32, where I would start, 32 times. Now I probably would put parentheses, and I'm going to hit a control divide. And it's 1 minus, I'm going to do it exactly the way I wrote it, parentheses and another control divide, 1 fourth. And it's not bad to practice the fractions. Maybe it won't be a nice fraction like 1 fourth that we can do decimal in our head. It might be, like, I don't know, 7 ninths. Right? And then to the 6th power. And then over 1 minus 1 fourth. Ugly, right? How do I get, do you guys remember how to get that to decimal? You get control enter, good. Learn that little trick that it gets you the decimal. 3 decimal places is what you're writing down. Alright? Alright. So once you learn how to use the tools, it's way better than Alright, 32, and then we said 42.636. What, 656? Oh, sorry. Alright, you okay with 13? Alright, let's look at 14 and let's talk about the parts and see if you can do this one more on your own. What's your n? It's 12, okay? And I know remember I said it doesn't matter if it's n or n minus 1 up here. There is a little issue with it being a little different. My first term in this case, because it doesn't say n minus 1, is not 4. So let's put that 1 in and see what happens. Sometimes maybe it's a good idea to put the 1 in every time. That's not going to make this a 1, right? It did make the exponent 0, so when it looks a little different, you got to be careful. Why? Go ahead and put that in your calculator. 4 times 4. Can't do it, man. Again, 1.2. So that is your first term. So there's your a sub 1. And then, but what's the ratio? It's still nice. 0.3 is still the ratio. All right, I want you to take a minute. I want you to try to plug that into the formula on your own and into the calculator. So write it out on your paper, what you can write in the calculator, and then type it in. The upside of writing it out like that, you guys, is if you make a mistake and you get an open-ended question on a test, you right, what'd you get when you hit the buttons? Great, what'd you get? 1.714, perfect. All right. So hopefully you got it written down the right way. All right. All right. Let's keep going. The next one's a little bit different. Okay. It wants us to write it in the summation notation to write the sum. So they want this funky, the E thing, right? The sigma notation, not an E, it's a sigma. All right. So they want us to write it like that. All right. So we need to figure out some things. All right. So I'm going to start with the sigma. I know that n is going to start at 1. The thing is, I don't know exactly where n is going to end yet. Okay, so I need to kind of figure that out. So let's go back to the formula we had yesterday. So we had a sub n equals a sub 1 times r to the n minus 1 power. Let's fill in what we know. Okay, because I don't know a whole bunch of stuff in between. Let's fill in what we know. Do we know the last term? Yeah, what's our last term? 896. Put it in the formula. All right. What's the first term? 7. Perfect. What about the ratio? Is it second minus first? Second divided by, because I'm in geometric, right? They didn't explicitly state that, but we are in a geometric thing, okay? We're in the geometric section. So I'm going to go and we're using a ratio. So 14 divided by 7 gives me 2. So my ratio is 2. I don't know n, right? So that's what I'm going to try to figure out. Okay. So, let's see. I could take this 7 and bring it to the other side. Okay, so let's help me out with the arithmetic. What's 896 divided by 7? 128, 2 to the n minus 1. Alright, we just came out of doing the log unit. There are multiple ways I can deal with this. I could take the log or the natural log of both sides and get that exponent out front. Or, without having to do the headache of logs, couldn't I get that to a base of 2, probably? What is it as a base of 2? 2 to the 7. Everybody check that out. 2 to the 7. We all agree with 128. We're okay with that? So now that my bases are the same, what can I do? Cancel them out. You got 7 equals n minus 1, n equals 8. Perfect. So I'm going to put that 8 up here at the top. And we actually wrote out already what's going to go in here. Here, we put this formula in it, right? That's what the kind of shortcut we saw in the last few. So I already wrote that out right here. I'm just going to put it here. 7 times 2 to the n minus 1. So you use your a sub n formula right there. Now, what if you didn't know what to do from here? Okay, got that in there, but I really forgot how to do exponentials and logs. I can still solve this problem. Okay, couldn't I figure out the dot dot dot? This really isn't that many terms. I can figure out the dot dot dot, right? I know I can still probably calculate my ratio. That's because if I got this far, I know I can get my ratio. So all I'm doing is multiplying by 2 every time, right? So help me out with the arithmetic. What is 28 times 2? 56 times 2. 112 times 2. 224 times 2. 38 times 2. How do I know to stop? I got that number. Couldn't I count up how many terms there are now? 1, 5, 6, 7, 8. Then I would know I'd have to put an 8 there. Okay? So there is another way to do it. I obviously didn't show you that first, because this is the better preferred way to do it. Just proving it to me algebraically. But that's a valid method right here. Okay? Now, if it had more than 8 terms, or it had 50 terms in it, we probably wouldn't want to do it that way. Okay? And likely you're going to lose track. Okay? Alright, we are going to do infinite today. Alright, we've got another formula. This is the last one of the 5. Alright? English is wrong. It should say sum of an infinite, right? All right. Sum of an infinite geometric sequence. So, believe it or not, it takes calculus to explain why this is true, but we can actually add it up. Okay, we can add up the sum of an infinite geometric sequence. Only under certain circumstances. Okay, so the formula is this: S stands for sum. A sub 1's what? First term, and the R is ratio. But there's a condition on the ratio. Okay, it says the absolute value has to be less than 1, meaning your ratio has to be between, I don't know why I wrote that has to be between -1 and 1. That's the only time when we can add up an infinite sequence. Okay? And the ratio is basically studied as a pretty small number. Okay? If we're outside of that, not possible. Okay? We'll go on. Right? Okay, so let's take a look at this one. Let's do a couple of these. So, same format as we had before. Looks like I can probably read it out of there. Okay, for the most part. I know it says we're going to find the infinite, and look at the top. See that infinity up at the top? So even if they said just find the sum of the geometric series, you should be able to know you're using your infinite formula to have an infinity at the top of the summation. Okay? So, our new formula, S equals A sub 1 over 1 minus R. Write it down and memorize it. That one's not so bad to memorize. It's not as bad as the first one. Alright, so, notice there's no subscript. Because there is no end, right? Alright, we're adding up all the terms. Alright, A sub 1, again, it doesn't hurt to plug that in, right? So let's see, 4 to the 0.6 to the 0. What's anything to the 0 power? Oh, yours says 1. Okay. Let's switch it to a 0. Okay, switch it to a 0. Sorry, that says 1. To make life easier to use 0. Right? So it's anything to the 0 power. 1. Okay, so 4 times 1 is 4. So my first term is in fact what it says there, right? 4. And then it is 1 minus, what's the ratio? We can still read it out of there, 0.6. Alright, put it here back to there. Don't yell it yet. Put it to the other chance. Believe it or not, it's a nice one. Alright, what do we get? It is 10. Alright? Look at that. We got it from 0 to infinity. Got 10. Alright, let's look at 17. Oh my gosh, that's left here. Okay. Alright, so 17, we're going to do our same. It says sum of an infinite, so I know I'm using S equals A sub 1 over 1 minus R. Alright, will this one say 0 or 1? Okay, so we're going to leave it 1 this time. I'm going to match yours, so that way you know what to do when we have the 1 there, and it doesn't say minus 1 here. Alright, so, first term, again, it doesn't, if it had an n minus 1 here, we would know it's 0 out, it just has an n, so I shouldn't really plug it in. So 5, 1/2 to the first. So really I get 5 halves of doing that. But if I knew that was 2.5, could I write 2.5 instead? Up to you, I don't care which way you do it. So I'm going to put 5 halves. That's actually 5 halves. Alright, and then 1 minus, what am I going to use for my ratio? 1/2. You want to go 2.5 and 1/5, right? ratio? 2/3. Final answer? 18. Alright, so the last one. Look at this. Is it bigger than 1? No, it's bigger than 1, right? So it says, if not possible, explain why. So I would say that it's not possible because r is greater than 1. And if you wanted to write down that r equals 5/3, just write that one